Hello friends, and today we will see 13 group element. In that today we will see the various properties, how it varies in 13 group elements series. Just day before yesterday we saw about the introduction of 13 group elements, then after their periodic table, their position in the periodic table, their electronic configuration, and we just started the periodic trend. In that first we saw atomic number. How atomic number changes? Atomic number changes, we know in the periodic table from left to right, atomic number goes on atomic size goes on decreasing, and from top to bottom atomic size goes on increasing. Right now, in 13 group element also it follows the same. From top to bottom, boron, aluminum, gallium, indium, thallium, atomic number increases, atomic size increases. But from gallium to thallium, gallium, indium, thallium, the growth in the atomic size is marginal. Means very much small amount of growth in atomic size occurs. Why? This is due to intervening effect. This is due to intervening of D and F block element. They have poor shielding for the outer electrons, and hence the force of attraction between nucleus and that of outer electrons is observed, because in between the D and F block element they do not shield the outer electron, and hence though the atomic size increase due to the increase in the force of attraction between nucleus and the outer electrons get slightly shifted inside, and hence atomic size though it increases but it is marginal, right now. And due to this, many other properties like ionization energy, electropositive characters also affected due to the size. Right now we will study ionization potential. Ionization potential, ionization energy. What is ionization energy? Yes, ionization energy is the amount of energy required to remove the outermost electron. Right now, we can since the outermost electrons are loosely held, right now, due to so much greater distance, that is far away from the nucleus has very small amount of force of attraction for the outer electrons, and hence these outer electrons, if they absorb energy from the surrounding, then they can overcome the influence of attraction force of the nucleus and can go outside the atom. Means completely it gets removed from the atomic shell, and this is nothing but the ionization energy. Every atom has different ionization energy, right? Then here we see, as from top to bottom size increases, the nuclear force observed also goes on decreasing from top to bottom. Yes, now we know atomic size increases, na? The nuclear force, it goes on decreasing, but we studied previously, for these three atoms increase in the atomic size is very marginal, na? It's marginal, and same happens with the ionization energy. From top to bottom, ionization energy goes on decreasing. But for these three, it is again marginal decrease. Marginal decrease. Why? Yes, because atomic size also have marginal increase. Right? And definitely ionization energy will also have marginal decrease. Now we will discuss metallic characters or electropositive characters of group 13 elements. What are metallic characters then? Yes, metallic characters are that metals are always good conductor of heat and electricity. Means they conduct heat and electricity. They are malleable and ductile. They are rigid. Malleable and ductile means when you hammer the metal, it won't break, but rather it will form a sheet. What is ductile? Ductility means when you put a force in opposite direction, yes, they won't break. Right now. Yes. Whether they will convert it into wire. This is ductility. These are the few properties, and definitely now let's study the metallic characters for 13 group element: boron, aluminium, gallium, helium, helium. We know metallic characters from top to bottom goes on increasing, and from left to right metallic characters decreases, right now. Then here also the same pattern is observed. Boron is non-metal. Aluminium definitely metal. And from here onwards metallic character increases. Right? This is about metallic characteristics. Talking more about the metallic characteristics. The boron is non-metal. Metallic characters increases from aluminium to thallium, but this increase is contrary to the regular trend. Boron is non-metal because the size is very small, right? And higher electronegativity. This indium, gallium, indium, thallium are less likely to lose the electrons. Though they have electrons, usually help, but these electrons are less likely to lose. Hence, increase in the characteristic metallic characteristic is marginal. Right? And is contrary to the regular trend. Next, the most important property is the oxidation state. What is oxidation state? It is the imaginary charge given over the atom. In our series 13 group element, boron, aluminium, gallium, indium, helium. The general electronic configuration, the general outer electronic configuration is ns2 np1, right? Means here 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1, and 6s2 6p1. And these are the valence electrons. These are the characteristics electrons. outer electron play an important role to decide characteristic of that atom, of that element. Right now, just like now you are in FY SY next year you will be in TY right? Means TY play an important role means in the market. Means if you take chemistry, you will be called chemist. If you take botany, you will be called botanist. And in TY, suppose you take zoologist, you will be called zoologist. Right? Means it gives a stamp over you. Definitely, you can become a graduate after taking TY. You can perform more TYs. Means another year you can take botany, zoology, depending on XY subject you have taken now. Right? Similarly, for the atoms, the last electron play an vital role, important role to decide the characteristics. Since here the NS2 and NP1 are the electrons, definitely these electrons are going to take part in bond formation, producing either +1 and total number of electron 3 +3. If +1 is there, then p electron take part in bond formation, and if oxidation state is +3, all these 3 electrons NS2 and NP1 take part in bond formation. Right? But here the 13 group element will show either +1 oxidation state or +3 oxidation state. For boron, it shows +3 oxidation state, as we know some compound of boron BCl3 BF3, right? We know it. It is in +3 oxidation state. Aluminium definitely it also shows +3 oxidation state because we know one important compound, anhydrous AlCl3, right? In Friedel-Crafts reaction. Okay. Now problem is here. From gallium, indium, thallium, what happens? This NS2 electron, these NS2 electrons, they are relaxed. They are relaxed from taking part in bond formation, and now no more these electrons are available. Right? They just get relaxed. You may call it as a sleeping electrons, right? Now, and they do not take, most of the time they do not take part in bond formation. It requires more and more energy to get excited. This is called as inert pair effect. Inert pair effect. That means the reluctance of these NS electrons, and hence gallium, indium, thallium, they show +1 oxidation state rather than overall +3. No doubt they show +3 oxidation state, but these two electrons are inert, relaxed, and hence only this one electron take part in bond formation, and 3 of them they show +1 oxidation state. For example, thallus and thallic. Thallus and thallic. Okay. Thallus compounds are more stable than thallic compounds because these two electrons require higher number of energy. As a result, from top to bottom, if you go, then stability of +3 oxidation state decreases, while that of stability of +1 oxidation state increases. Got it? Stability of +3 decreases, whereas stability of +1 oxidation state increases. Why this happens? This happens due to inert pair. This is all about oxidation state. Now last property we will see, melting point and boiling point. You know what is melting point and boiling point. The temperature at which the solid melts is melting and boiling point. The liquid vaporizes is the boiling point, right? Now these are the simple definition. Now talking about group 13 elements, the change in melting and boiling point is rather not in regular trend. That means it is irregular. How it increases, decreases, there is no particular pattern in the periodic table for a 13 group element. Why? Because it depends on the structure, which structure they occupy. Definitely boron have high melting point. This melting point from aluminium to indium, it goes on decreasing because this all other structure show close packing. They have close packing structure. What is close packing? Have you seen a bunch of grapes? How actually the structure of grapes form, that structure of grape bunch forms. If you study the grapes of the bunch of grapes, that grapes are so much close to each other, very much closer to each other. Means in between they have so much less amount of void space, right? Now like this somewhat, right? Okay, fine. Void space means this. And what can we say about this? There is lot of void space, na? And hence they show close packing. But the gallium do not show close packing. Gallium do not show close packing. Rather, it will present in diatomic molecule. Rather, it forms diatomic molecule. And hence, since it is in diatomic, no packing structure is observed. Melting point will be the lowest in the series. Right now, since gallium shown, it will melt easily due to diatomic molecule state. But again for thallium, melting point increases. Right? Got it? Means boron definitely have high melting point. Aluminum, gallium, indium. From here onwards, melting point decreases. Gallium it is present in diatomic state rather than close packing. Therefore, gallium have the lowest melting point in the series. And then for thallium, it again increases melting point. Talking about boiling point. Boiling point of boron is definitely high. But further, it goes on decreasing. Boiling point decreases from top to bottom. So boiling point of gallium, though it is in diatomic state, it is in line with others. This is due to it forms diatomic rather than closest packing. Secondly, gallium in liquid state it expands. Gallium in liquid state it expands to form solid. Right? And hence its melting point is remarkably low. Okay. Then about the revision of today's lecture, what we have seen, we have studied at periodic trend like atomic size, ionization energy, metallic characteristics, oxidation state, and the last we have studied melting point and boiling point. Okay. Tomorrow we will see deficient molecules in group rating. Okay. Till then, have a nice day. Thank you.